You know, in every single digital device you own, your phone, your laptop, everything, there's this incredible, nonstop flood of data. But have you ever stopped to wonder how it's all managed, right down to the individual ones and zeros? Well, in this explainer, we're going to pull back the curtain on the tiny, fundamental components that make it all work. So let's just start with that big question. How in the world does a processor, which is juggling billions of things a second, manage to precisely control information one single bit at a time? I mean, the timing and coordination required for that is just mind-boggling. Well, the answer is actually really, really clever. It turns out computers use what you can think of as digital traffic cops that direct the flow of all those bits with absolute precision. And they're called shift registers. They are truly the unsung heroes of digital logic, so let's dig into how they actually work. Okay, first things first, let's look at the core idea here, the shifting mechanism itself. How do these little traffic cops actually get the data to move down the line? So, by definition, a shift register is a sequential circuit. All that means is that what it does next depends on what it did before. And it's built from a chain of things called flip-flops. You can just think of these as tiny little storage cells that can hold a single bit, a 1 or a 0. Now here's the magic. With every single tick of the system's clock, the data inside gets pushed or shifted one spot over. And that's the key. It doesn't just store data, it actively moves it. The best way to picture this is like a little conveyor belt for bits. Okay, so imagine we start with the number 1011 loaded up. The clock ticks once, boom, everything scoots one position to the right. That last one just falls off the end, and a new 0 gets fed in at the beginning. The clock ticks again, it happens again, and again. It's this super simple but incredibly powerful rhythmic movement that's at the heart of every single shift register. But, of course, it's not a one-size-fits-all deal. It turns out shift registers come in 4 main flavors. And each one is specialized for a different job. All based on a simple idea: how they get data in and how they get it out. This table lays it all out for us. You've got serial in, serial out, or SISO. Think of that one as just a simple delay. Then there's serial in, parallel out, SIPO, which takes a stream of bits and presents them all at once. PISO does the exact opposite, taking a big chunk of data and feeding it out one bit at a time. And finally, you have PIPO, parallel in, parallel out, which is basically just for holding on to data for a moment. The whole game is about how the data moves, one by one, which is serial, or all at once, which is parallel. Now, let's really focus on those two converters, SIPO and PISO, because they are absolutely critical. Think of it like this. SIPO is like people on a bus getting off one by one to form a crowd on the sidewalk. PISO is that whole crowd getting back on the bus in a nice, orderly, single-file line. This ability to switch between a line of data and a group of data is fundamental to how almost all modern communication works. Okay, so we've got all these specialists, but you might be thinking, isn't there one that can just do it all? Well, you are in luck. Let's meet the Swiss Army knife of registers, the Universal Shift Register. This thing is the real MVP. The Universal Shift Register is a single, programmable powerhouse that can do everything we've talked about. It can shift data to the left, shift it to the right, load it all at once in parallel, or just do nothing and hold the data as it is. It really is the ultimate all-in-one tool for shuffling bits around. So how does it know what to do? Simple. You just give it commands with a couple of control inputs. You send it a 00, and it knows to just hold steady. Send it a 01, and boom, it starts shifting everything to the right. A 10 tells it to shift left, and a 11 tells it to load a whole new set of data all at once. It's this incredibly simple control scheme that makes it so powerful and flexible. And hey, quick pro tip here for any students watching. Because this one device can do basically everything, it is an absolute classic exam question in digital electronics. So for real, if you're hitting the books, make sure you know this one inside and out. You can thank me later. All right, so this is all great theory. But let's get to the so what of it all. Why does any of this actually matter? Where do you find these things working in the real world? The short answer is pretty much everywhere. They're used constantly for just moving data between different parts of a computer. They create the precise timing delays you need for digital audio and video effects. That Wi-Fi or internet cable you're using, it relies on them to convert data. They're also a cornerstone of digital signal processing, and even act as a kind of super fast temporary memory right inside the core of a CPU. Now, we've been singing their praises, but let's be real. No technology is perfect. As amazing as shift registers are, it's important to know their trade-offs. Yeah, they're simple and fast, but are there any downsides? So here's the deal. On the one hand, their biggest pro is their elegant simplicity and their speed. For moving and manipulating data, they are fantastic. But on the flip side, they're not great for storing lots of data. They're sprinters, not marathon runners. The more bits you want to store, the more complicated the hardware gets. And of course, they need that constant ticking clock pulse to do anything at all. And that kind of leaves us with a big final question to think about. The shift register is, without a doubt, one of the foundational building blocks of our entire digital world. But as our appetite for data and processing power just continues to skyrocket, you have to wonder, are these simple, elegant little components still going to be enough to handle the challenges of the future? Something to chew on. Thanks for watching.